Let's play around a little bit today with the third dimension. So let's say you have a system, and this time in your system you have three variables. So what would that look like, a system with three variables? So far we've been working with the x and the y-axis, and the x-axis is our horizontal axis. The y-axis is our vertical axis. Now, if I have a z-axis, then that z-axis is going to cut across both of those into the third dimension. So that's the third dimension. So let's think of that axis. Now we have three axes, right? We're going to think of those three axes. That z1 is going to be our third dimension. So if I look at a system that's got three variables, x, y, and z, we're going to think of z as the third dimension, then we're going to look at where they might intersect and to determine whether they have no solution, one, or an infinite number of solutions. So let's look at this one. So we have here, here, and then we have that third dimension over here. So those don't intersect. There's no point that has all three lines. Same thing here. So you have one here, you have one here, you have one here, but all three have to have an intersection. And then over here you have parallel planes. So in that system, you have that whether they look like this, this, or this, no point lies in all three planes, so you have no solution. You can have one solution here, and see that one solution? That lies right there where they all three intersect. So that's one solution. Now an infinite number of solutions, the planes intersect at all the points. You see that? They intersect at all the points, everywhere they intersect. So one of the ways that we're going to solve a system that's got three variables is we're going to use elimination. So let's go over and take a look at a system. We're going to take a look at that system by solving it using elimination. Then we're going to go over to Desmos and check our solution. All right, so we've got a system here. I'm going to make that bigger. We've got 2x minus y plus z equal 4. Next we have x plus 3y minus z equal 11. Next you have 4x plus y minus z equal 14. All right, so step one, we're going to pair each equation. We're going to pair, that meaning 2, to eliminate z, okay? So we're going to pair the first and the second one first. So we've got 2x minus y plus z equal 4. And then we've got x plus 3y minus z equal 11. All right, I'm going to add. So I've got 2x plus 3x. That gives me 3x. And then I got minus 1y plus 3y. That's plus 2y. 11 plus 4 is 15. All right, so I've got a new equation. I've got 3x plus 2y equal 15. Let's do that with the second and the third one, okay? So we've got x plus 3y minus z equal 11. And I've got 4x plus y minus z equal 14. All right, so that gets me x minus 4x, so that's minus 3x, plus 2y, so I subtracted those, and then I've got 11 minus 14, that's going to be negative 3. All right, so I've got it down to 2 over here. So now I'm going to write these two new equations. So that was step one. Now, we paired them to eliminate z, and then we got two equations in x and y. Why did we subtract the second set? So we could eliminate z. So we changed the sign on all of these, right? So that gave us a minus z plus. So I had to make that a minus. I had to make that a minus, etc. That's how we got there. All right, so step number 2. Now let's write these two as a new system and go to the elimination. So we've got 3x plus 2y equal 15. And I've got negative 3x plus 2y equal negative 3. All right, those go away. So I've got 4y equal 15 minus 3, 12. Divide both sides by 4. So I've got my y value of 3. All right, so I've got a y value of 3. Then I can substitute that y value in. Still on step 2, so we're going to substitute it in. So we've got 3x plus 2y equal 15. Now let's substitute. We've got 3x plus 2 times 3 equal 15. We've got 3x plus 6 equal 15. Subtract 6 from both sides. So we've got 3x equal 15 minus 6. That's 9. Divide both sides by 3. That leaves us x equal 3. All right, so I've got a y value of x and a y value of 3 and an x value of 3. So the third step is we're going to solve for z by substituting. So I'm going to go over here just so that we have everything on the same space, okay? So we've got a y value of 3, an x value of 3. We're going to substitute in and solve for z. So we've got 2x minus y plus z equal 4. So 2 times 3 minus 3 plus z equal 4. We've got 6 minus 3 plus z equal 4. 3 plus z equal 4. Subtract 3 from both sides, so then z equal 4 minus 3, which is 1. All right, so we've got what's called a ordered triple, right? We've been working with an ordered pair, x and y, so we put them in order. So we've got an ordered triple of 3x, y, and z. So 3, 3, 1 is the solution to that triple. Now, I'm going to go over to Desmos, and we're going to think of that third dimension, and we're going to use a slider to look to see what our solution is to check our work. All right, so we got 3, 3, 1. What I did here in Desmos was I typed in the first equation from the original system, 2x minus y plus z equal 4. So that's your red line, that's this one. I've got the second one, x plus 3y minus z equal 11. That's my blue line, that's this guy. And then my orange one is 4x plus y minus z equal 14. Now when I did this, my z, which is my third dimension, gave me a slider. So I said originally that the z solution was 1. So notice what we're going to do on our slider is we're going to see that where the 3 intersect, if that is indeed at 1. So right now we are at 0.8 and there's 1. So there's our solution right there to that. We got 3, 3, and 1 where we used our slider to get to that intersection. So what you do in Desmos, I'm just going to zoom in here. Notice that your slider, wherever it starts at, what you have to get it to is to that where they intersect with each other. And you get at z equal 1, that's the intersection. Therefore, your triple, your solution is 3, 3, 1. How cool is that? You can also use a substitution like we did in a linear system that had 2 equations in the system. Now this one we have 3, but you can also use substitution to do that. Once you use substitution, then you can come over to Desmos, and because I want you to practice using Desmos and using that slider to find your solution to that system, let's input another system with 3 variables. So in this system we've got 2x plus 3y minus 2z equal negative 1. And let me grab that over there because it's way down there. Okay, the next one in the system is x plus 5y equal 9. All right, and I'm way over here, so I've got to make sure. All right, and then I've got 4z minus 5x equal 4. All right, so we've got a system that sort of looks like this, right? So now we've got our z value here, and we're trying to slide it over until we have an intersection. So let's slide it. We're almost there. And if you've used substitution, then you can see that your xy value then here, so you've got 4, 1, and then your z value is 1. So once you solve this system, you've got that your z value, your x value, your y value, and your z value. So you've got a 4 and a 1 and a 1. So if you were asked, for example, in a question, what is the x value in that system? Well, you know that that x value is 4, right? If you were asked, what is the y value? You know that the y value is 1 based on your graph. And if you were asked, what is the z value? Well, you know that the z value is 6 because that is the point of intersection when you use your Desmo graph, where they in all 3 lines intersected. That made your z value of 6. Isn't that really cool? So I do want you to play with those systems and get your solutions. You can use substitution, elimination, and then graph to be absolutely sure what your z value is as well. Have fun with that. It's really cool to get that done because there are some problems that we can solve that are going to get us some real solutions.